You sit down at your desk with full intention to work, and within 90 seconds, your brain feels like it is suffocating in complete silence. You reach for your phone without deciding to reach for your phone. You open 3 tabs you do not need. You clean a corner of your desk that was not dirty. This isn't a personal failure of willpower. Your brain is solving a biological survival equation that modern productivity culture completely misunderstands. Popular internet culture tells you that you are addicted to cheap dopamine. It tells you that you need to go on a hard reset, dopamine detox, fast from all pleasure, and sit in a quiet room until your focus magically returns. For a neurotypical brain, stepping away from hyperstimulation can help reset baseline motivation. For an ADHD brain, a traditional dopamine detox often backfires spectacularly. Instead of feeling restored, you experience intense restlessness, physical irritability, executive paralysis, and an overwhelming surge of internal noise. Why does a method that works for millions of people leave your nervous system in absolute chaos? To understand why, we have to look deep inside the neurological machinery of attention, reward processing, and chemical transmission in the human brain. In landmark brain imaging studies led by Dr. Nora Volkow, director of the National Institute on Drug Abuse, positron emission tomography scans revealed that adults with ADHD possess significantly fewer dopamine D2 and D3 receptors, as well as lower transporter densities in key reward pathways, particularly the nucleus accumbens and ventral tegmental area. In plain English, dopamine is the essential chemical messenger responsible for anticipation, motivation, and filtering background noise out of your consciousness. When your brain has fewer functional docking stations for dopamine, your baseline level of neurochemical engagement, what neuroscientists call tonic dopamine, is chronically low. A neurotypical brain sits at a comfortable resting baseline, like a car idling smoothly at a stoplight. An ADHD brain sits below that idling threshold. When your tonic dopamine is low, routine tasks like filing paperwork, reading a dry textbook, or organizing a kitchen drawer feel physically uncomfortable. Because your brain lacks the baseline neurochemical signal required to sustain attention over time. To compensate for this chronic deficit, your brain constantly hunts for phasic dopamine hits. Rapid spikes in chemical release triggered by novelty, urgency, risk, or high-intensity stimulation. When self-proclaimed productivity experts tell you to execute a cold-turkey dopamine detox, they are asking a brain with an already deficient dopamine baseline to enter a state of total neurochemical starvation. Dr. Russell Barkley, one of the world's leading clinical psychologists and researchers on attention disorders, has demonstrated across decades of landmark research that ADHD is fundamentally not a failure of knowledge. It is a failure of executive function, self-regulation, and temporal discounting. Temporal discounting is the brain's automatic tendency to discount the value of a reward the further away it sits in the future. In an ADHD brain, temporal discounting is severely exaggerated, meaning a future goal holds almost zero motivational weight compared to what is happening right now in front of your eyes. When you strip away all immediate stimulation without providing a structured baseline support system, your executive functions do not reset. They collapse into total dysfunction. This structural reality is reflected in major diagnostic and treatment frameworks worldwide. From the Diagnostic and Statistical Manual of Mental Disorders, 5th edition, to the UK National Institute for Health and Care Excellence Guidelines. Clinical guidelines consistently emphasize that environmental modification and behavioral scaffolding, not sensory deprivation, are essential for managing executive deficits effectively. So why do standard self-discipline protocols break down so completely when you apply them to your daily life? Let us walk through what actually happens inside your brain during a low stimulation attempt. You take your phone and put it in another room. You close every tab on your computer screen. You sit down in front of a blank document or a stack of papers. For the first 2 minutes, your prefrontal cortex, the command center of your brain responsible for impulse control, working memory, and goal-directed planning, tries to hold the line. Then your default mode network begins to surge with intense, unchecked activity. The default mode network is an interconnected web of brain regions that naturally activates when you are resting, daydreaming, or not engaged in a focused task. In a neurotypical brain, when you sit down to focus on a task, your task-positive network turns on, and your default mode network automatically powers down. In an ADHD brain, as documented in neuroimaging research published by Dr. Stephen Farion and colleagues, these two neural networks fail to alternate smoothly. They fire simultaneously, competing directly for control of your conscious attention. Without external stimulation to anchor your task-positive network, your default mode network completely takes over, unleashing a relentless flood of internal chatter, unorganized memories, suppressed anxieties, and sudden creative impulses. Your nervous system experiences a rapid surge of norepinephrine, the chemical messenger responsible for physical arousal and fight-or-flight activation. Your legs begin to bounce rhythmically. Your jaw tightens without you realizing it. You feel an urgent, almost painful physical itch to move, to search, to check something, anything. This is not a lack of moral discipline. This is your nervous system frantically attempting to raise its own internal heart rate and chemical arousal to reach a functional state. If you attempt to stay in that low stimulation state without proper scaffolding, your brain does not magically settle. It enters what cognitive scientists call executive paralysis or functional freezing. You sit frozen in place for 2 hours, doing no work, receiving no rest, generating immense stress and accumulating deep emotional guilt. Is an effective neural reset actually possible for an ADHD nervous system? The short answer is yes, but it looks completely different from the extreme deprivation pushed by viral social media trends. A true neurodivergent neural reset is not about chemical starvation. It is about recalibrating your stimulus threshold through environmental engineering. Dr. Thomas E. Brown, a renowned clinical psychologist specializing in executive function, explains that the ADHD brain is fundamentally interest-based and stimulation-dependent. Your brain cannot regulate attention through sheer willpower or moral demand. It regulates attention exclusively through optimal physiological arousal. To lower your stimulation threshold without triggering executive paralysis, you must systematically replace high-speed, unpredictable dopamine hits with low-yield, predictable, sensory-stable inputs. Consider what happens inside your head when you swap rapid digital consumption for low-variance physical tasks. When you engage in low-variance stimulation, such as walking on a familiar outdoor trail, listening to structured brown noise sweeping a floor, or assembling a physical puzzle, you are not starving your brain. You are providing your nervous system with just enough low-level, steady neurochemical input to keep the default mode network quiet, while allowing your dopamine receptors to slowly upregulate. Neuroreceptor upregulation is the biological process where your brain cells increase the sensitivity and physical density of their receptors when massive bursts of artificial stimulation are reduced. Over time, when you spend hours scrolling short-form videos, switching between browser tabs, or chasing immediate novelty, your brain experiences chaotic, unnatural spikes in phasic dopamine. In response to this neurochemical flood, your synapses protect themselves through downregulation, dialing back receptor sensitivity so you do not burn out from overexcitation. This is precisely why normal life feels flat, boring, and impossibly grueling after a long session of high-speed digital consumption. Your brain isn't incapable of enjoying quiet tasks. Its receptors have simply dialed down their volume control to survive the sensory noise. The solution is not to lock yourself in a stark room with zero sensory input. The solution is to introduce gentle, friction-filled stimulation that stabilizes your tonic dopamine line and allows your receptor volume to turn back up. What does a science-backed, neurodivergent-friendly neural reset look like in your actual daily life? First, you must eliminate high-velocity novelty while deliberately retaining ambient sensory engagement. Instead of demanding total silence, which only amplifies internal chaotic thought loops, introduce structured acoustic environments like brown noise or repetitive instrumental soundscapes. Clinical research on stochastic resonance, a mechanism where optimal background noise enhances signal detection in underdoused neural circuits, shows that steady ambient sound can significantly improve working memory and cognitive focus in individuals with ADHD. Second, reduce input velocity, rather than trying to eliminate input entirely. Reading a physical book or working on a manual craft generates a slow, steady trickle of dopamine through continuous physical and mental effort. Whereas scrolling a feed delivers rapid, effortless reward hits with zero friction. Your brain actually requires physical or mental friction, because effortful engagement triggers sustained noradrenergic release that anchors your prefrontal cortex to the task at hand. Third, protect your morning neurochemical transition window. When you wake up in the morning, your cortisol awakening response sets the baseline sensitivity for your entire nervous system for the next 16 hours. If the very first input you give your brain upon waking is a high-dose burst of algorithmic novelty from a smartphone, you immediately set your dopamine threshold at an unachievable height for the rest of the day. Every normal, real-world task after that moment will feel excruciatingly slow and understimulating by comparison. By protecting your first 30 to 60 minutes from high-velocity screens, you allow your natural tonic dopamine baseline to settle at a healthy, functional level. Dr. Adele Diamond, a pioneer in the developmental cognitive neuroscience of executive function, emphasizes that executive control is highly sensitive to small changes in stress, emotional state, and physiological balance. When you force your brain into artificial deprivation, you spike cortisol and trigger a survival state that dismantles the precise cognitive tools you are trying to restore. When you instead provide structured, low-intensity engagement, your nervous system feels safe enough to lower its defenses and rebuild focus naturally. You are no longer fighting against your neurobiology. You are working in harmony with the exact operating rules of your neurodivergent nervous system. Understanding this fundamental scientific reframe transforms how you view your daily productivity and mental fatigue. You are not broken. You do not possess a defective or lazy mind that needs to be punished into submission through extreme sensory deprivation. Your brain is simply an ancient, highly sensitive organ wired for optimal stimulation, navigating a modern environment engineered for continuous high-frequency extraction of your attention. When you give your nervous system the right kind of steady, low-yield engagement, the frantic urge to escape into distraction begins to fade naturally. Executive control is never achieved by shutting down your brain's biological demands. It is achieved by meeting those demands with intelligent, respectful structure. You sit down at your desk with full intention to work, not because you forced your brain into silence, but because you finally understood what it was asking for.